take here. So the value of n is equal to 4. So that the Twiddle factor can be taken as, so here a can take the value from 0 to the n minus 1. So which is nothing but 0 is less than a is equal to 3. So here the Twiddle factor values we need to take omega 4 to the power of 0. We need to find out omega 4 to the power of 1, 2, 3 like that. So in order to find the values, we can find out in the two methods. We can, one is expressing in terms of the exponential series, and that exponential series we can express in terms of the cos and sine function. Let us do that one. So the general form that we take here, so it is omega 4 to the power of a, I can express as e to the power of minus j2 pi divided by 4 into a. So this one we can express as a, so it's a cos 2 pi. So here 2 ones are 2 2s will get cancelled. So it is cos pi by 2 minus j sine 2, that is pi by 2 into a. Let us substitute the value for this one, and we can find the values for the Twiddle factor here. Let us take a is equal to 0. If I substitute a is equal to, so that will become omega 4 to the power of 0 will get. So it is nothing but omega 4 to the power of 0 is nothing but it is e to the power of 0. This will be equal to 1. So this value we got omega 4 to the power of 0 will be equal to the 1 will get here. So similarly, let us find out the remaining values for a is equal to 1. So it is omega 4 to the power of a. So which is nothing but the 1 will let us take here. So omega 4 to the power of 1. Let us find out that value. So here if I substitute a is equal to 1 here, if I substitute a is equal to 1 and here also a is equal to 1, let us see how the values will become. So it is omega 4 to the power of 1. So this we can write as, so cos pi by 2 minus j sine pi by 2. So cos pi by 2 is nothing but it's a cos 90 will be equal to 0, and sine pi by 2 is nothing but it minus j will get here. So that is omega 4 to the power of 1 is nothing but minus j will get. So similarly, let us find out the value for omega 4 to the power of 2. So omega 4 to the power of 2 is nothing but, so it will become the value of a will become equal to the 2 here. Let us substitute that one. So it is cos pi into 2 divided by 2 minus j sine 2 pi divided by 2. So 2 2 will get cancelled. So here also 2 2 will get cancelled. So cos pi is nothing but minus 1. Already we have seen that one. And sine pi is nothing but 0. So this will become equal to minus 1 will get. So we got the value for omega 4 to the power of 2 will be equal to the minus 1 will get here. So similarly, let us find out the value for the another value, that is omega 4 to the power of minus 3. Let us look into that one. So omega 4 to the power of minus 3. Sorry, omega 4 to the power of 3 earlier, let us find out here. So it is omega 4 to the power of 3, which is nothing but, so it's a cos 3 pi by 2 minus j sine 3 pi by 2. So cos 3 pi by 2 is nothing but cos function, that is cos pi by 2 or cos 270 we can call. This will be equal to the 0 will get, and sine pi by 2 is nothing but sine 3 pi by 2 is equal to the minus 1 will get here. This is equal to the minus 1. So minus 1 into minus j will become equal to the plus j will get. So that is omega 4 to the power of 3 is equal to the. So in general, we can represent the Twiddle factor values with the values like this. So omega 4 to the power of 0, this is equal to 1, and omega 4 to the power of 1 minus j. Omega 4 to the power of minus 2 is minus 1, and omega 4 to the power of 3 is equal to the plus j. So as I told in the previous sessions, we have the Twiddle factor is going to exhibit the periodicity property. That is, it is going to exhibit like this. So at this is a is equal to 0, a is equal to 1. So this is plus 1, and a is equal to the 2, and a is equal to the 3. So this is 1. So minus j, minus 1, and plus j. So even this is also equal to the omega 4 to the power of 4 is also equal to same, and even omega 4 to the power of 8 is also same value. Omega 4 to the power of 1, and this is also equal to omega 4 to the power of 5, and this is also equal to the omega 4 to the power of if you add 4 this one. And similarly, this value is also equal to omega 4 to the power of 2 and omega 4 to the power of 6, and this is also equal to the omega 4 to the power of 10, and this is also equal to the this is also equal to the we can have this value. It is also equal to the this value is also equal to the this is also equal to the omega 4 to the power of 3 is also equal to the omega 4 to the power of minus plus 3 is also equal to the omega 4 to the power of minus 1, and even this is also equal to the omega 4 to the power of 7. All those things will be there. The Twiddle factor value will be taken like this. So let us okay. So this is how the Twiddle factor values will be considered, and we can find out the Twiddle factor values. We can find out like this. So this is how we can find out the Twiddle factor values. Now let us look into the how to find out the properties of the signal. Let us find out the periodicity property we have seen, and similarly we can apply the symmetry property also. We can apply here. What the symmetry property says is that so omega 4 to the power of n by 2. So this is also equal to the omega 4 to the power of that is minus 1 into a will get here. This is called as the symmetry property. Let us apply that one also, and let us verify the symmetry property also here. So what it says is, so if I know the half of the values, the remaining half we can find out like this here. So here just have a look into this one. So what we'll do is, so omega 4 to the power of a plus the value of n by 2 is nothing but it is 2 here. So if I want to find out the value for omega 4 to the power of 3, so this is also nothing but I can express this one as omega 1 to the power of omega 4 to the power of 1 plus 2, where the value of a is nothing but 1. So by applying the symmetry property, it is equal to the minus omega 4 to the power of 1. So we know the value for omega 4 to the power of minus 1. Sorry, omega 4 to the power of 1 is minus j. So minus j multiplied by minus 1, this will become equal to the, so it will become equal to the plus j will get here. So this is minus 1 multiplied by the minus j. So this will become equal to the plus j will get. So that is what the symmetry property we can apply in order to find the values for the sequences. And this one will reduce the number of calculations. So like this, we can find out the Twiddle factor values by manually we can find out here. So similarly, we can find out the Twiddle factor value by using the polar format we can find out here. So how to find out is, so we have omega 4 to the power of a is there, or let me take this in general as omega n to the power of a. So the exponential form we can express as e to the power of minus j2 pi a divided by n. So this one we can express in terms of the polar format like this. So it is 1 at an angle of minus 2 pi into a divided by n. We can express in the polar format here. We can take this formula in the calculator, and we can substitute the value of n, and we can substitute the value of a, and a as the generic value we can substitute, and n let us substitute the corresponding value of the n, let us substitute here, and we can find out the value for the Twiddle factor we can find out here. So this says that by using polar format and by using the calculator, we can find out the value by substituting a is equal to 0, 1, 2, 3, and this is a second method of finding the Twiddle factor values. So similarly, let us look into the factors related to the properties of the Twiddle factor. So one property is that the Twiddle factor is going to satisfy one generic property. The property says is, let us have a look into that one. So what it says is that is omega, that is summation. It can be expressed like this: summation n is equal to 0 to n minus 1 omega n to the power of k into n. So this is equal to n. This value equal to n if suppose k is equal to the 0, and this value will be equal to 0 suppose if k is not equal to the 0. So let us prove this one. This is one of the important property where we can applicable this one in the many problems will do applicable here. So in order to prove this one, I'll consider the LHS part here. So let me take the LHS part. LHS part here, what it says is summation n is equal to 0 to the n minus 1. So it is can be expressed as omega n to the power of k to the power of n we can express here. So in order to evaluate this one, I'm going to consider the sum of finite terms formula we'll consider. So we know that, so what we know is summation n is equal to 0 to the n minus 1. So a to the power of n, it is equal to the 1 minus a to the power of n divided by 1 minus a. So provided a should not be equal to the 1 here. So I'm going to call this as the equation number 1. I'm going to call here. So let us evaluate that one by applying this formula. Let us evaluate the LHS part. So the LHS part will become equal to, so what we'll get is, so it is 1 minus omega into the power of k into capital N. So divided by 1 minus omega into the power of k. And the condition is that, so this omega into the power of k should not be equal to 1. So the condition is that the omega n to the power of k should not be equal to 1. So this implies that k should not be equal to 0. The k should not be equal to 0. So here omega into the power of k into n. So this is equal to the 1 here. So this LHS part will become equal to 0. We'll get here for the case k is not equal to the 0. So we got the first proof we got here. That is for k is not equal to 0. We got it is equal to the 0 we got here. Now let us substitute k is equal to 0 in the equation 1 and we'll evaluate that proof. Let us evaluate that one. So we'll consider in the equation 1. So in the equation 1, we'll substitute k is equal to 0. So this will become, the equation 1 will become like this. So it is summation n is equal to 0 to the n minus 1 omega n to the power of 0. So omega n to the power of 0 is ultimately 1. So summation n is equal to 0 to the n minus 1. It is equal to 1. If I'm going to take the 1, the sum, if you take n times, this will become equal to the capital N will get. So this is for the value k is equal to the 0. So we can, let us summarize this value. Let us summarize this value. So what we'll get is summation n is equal to 0 to the n minus 1 omega n to the power of kn. So this is equal to n if k is equal to the 0, and this will be equal to 0 if k is not equal to the 0. So this is one of the property of the Twiddle factor where we can apply and evaluate the problems, and this property will be useful in order to find out the Twiddle factor of the